n equivalent to 2 power 15 into, there is a natural number that is given. Another beautiful question, sir. 2 power 15 into 3 power 7 into 5 power 10. How many factors of n are there which are multiples of 360 but not multiples of 10,800? Let there be a circle. These are nothing but the factors of n which are multiples of, I'll write like this. These are nothing but the factors of n which are multiples of 360. This circle represents all the factors which are multiples of 360. Let there be another circle. Factors for n which are multiples of 10,800k. Any multiple of 10,800 is nothing but 10,800 into something. That something I call it as k. What is that we require? How many factors for n in this circle are multiples of 360 but not multiples of 10,800? These shaded region we require. These shaded region we require. These shaded region is nothing but total factors which are multiples of 360 minus factors which are common to the multiples of 360 and 10,800. From this red circle, if I remove that blue shaded region, I will get the region which we require it. So it is nothing but, question is nothing but factors of n which are multiples of 360. Factors of n which are multiples of 360. From this circle, if I subtract the factors which are common to multiples of, which are common to multiples of, once you see the Venn diagram it will be clear. Common to multiples of 360 and 10,800, I will get the required answer. I hope it is clear. These shaded region I require. These yellow color region I require. Yellow color region I require, it is nothing but total circle minus the circle which is common in both the regions. Factors for n which are common to multiples. Common to multiple is nothing but the LCM of 360 and 10,800. 10,800 is a multiple of 360. So it is nothing but 10,800. One by one we will go. One by one. Very, very good questions. N is 2 power 15 into 3 power 7 into 5 power 10. First question. Factors for n. Factors for n which are multiples of 360. Any multiple of 360 is of the form 360 into something. 360 is 8 into 9 72 into 5 360 into what is remaining. For 2 power 15 2 power 3 is taken, remaining is 2 power 12. 3 square is taken, remaining is 3 power 5. 5 power 1 is taken, remaining is 5 power 9. These are the numbers which are multiples of 360. How many factors are there for this number? 12 means 13 factors, 5 means 6 factors, 9 means 10 factors. So total 780 factors are there which are multiples of 360. 780 factors are there which are multiples of 360. Next one. Factors for n which are common to multiples of 360 and 10,800, which is nothing but 10,800 into k, which is nothing but 360 into 30. 30 it is nothing but 2 into 3 into 5. 360 it is 2 cube into 3 square into 5 power 1. So 2 power 3, 2 power 1, 2 power 4, remaining is 2 power 11. 3 square 3 power 1, 3 cube, remaining is 3 power 4. 5 power 1, 5 power 1, 5 power 2, remaining is 5 power 8. These are getting multiplied by 10,800. How many factors are there for this number? 2 power 11 means 0 to 11, 0 to 4, 5, 0 to 8, 9. So these nothing but 60 into 9, 540. From these 780, if I subtract the factors which are common, I will get the factors which are multiples of 360 but not multiples. 780 minus 540. Answer is nothing but 240. Answer is nothing but 240. Very, very good question, sir. These are total 780 factors. In that, 540 factors are common to both. What is remaining? 780 minus 540. Remaining, it is nothing but 240. Out of 780 factors, 540 are common to both 360 and 10,800. But the question is, but not multiples of 10,800. So out of 780, 540 are common, remaining is 240. Very good level question, sir. Next one. How many n equivalent to? I think it is also a similar question. N equivalent to 2 power 8 into 3 power 10 into 5 power 8 into 7 square. There is a number. How many factors for n are multiples of 360? These are the factors which are multiples of 360 but not multiples of 540. This circle represents the factors which are multiples of 540. This circle represents the factor which are multiples of 360. This region I require. Same approach. Whatever we did in the previous question, same idea. If we do it, we will get the answer. So these is nothing but total circle minus this region. If I take, I will get the required region. So step number 1, factors for n which are multiples of 360, 360k, 2 cube into 3 square into 5 power 1, 2 power 8, 2 cube taken out, 2 power 5, 3 square taken out, 3 power 8, 5 power 1 taken out, 5 power 7. Remaining is 7 square. These are the numbers getting multiplied by 360. How many factors are there? 6 into 9 into 8 into 3. 6 9s are 54, 54 into 24. 162 into 8. These are the factors for n which are multiples of 360. Factors for n which are multiples of 360 but not multiples of 540. Take the number which is a multiple of 360 and 540. LCM of 360, 540, which is 1080. 1080. We have to remove the factors which are common in both. These nothing but 30 into 360. 2 into 3 into 5. 360 is 2 cube into 3 square into 5 power 1. 2 cube 2 power 1, 2 power 4. Remaining is 2 power 4. 3 square 3 power 1, 3 power 3. Remaining is 3 power 7. 5 square 5 power 6 into 7 square. These are nothing but 5 into 8 into 7 into 3. Subtract 40, 43s are to 120, 840. Subtract this from this, you will get the answer. I hope this model is very, very clear to you. He is giving you a number. He is asking you to find out the factors which are multiples of 360. In that, there are certain factors which are also a multiples of 540. We have to remove it. Factors which are multiples of 360 we will find out. Factors which are multiples of 360 and 540 we will find it out and subtract. Once we subtract, we will get the answer. I hope the idea it is clear. Very, very good advanced level questions which we are discussing. Now, previous question it is talking about the multiples. In this question he is talking about only the factors. Now, let us read the question. Question is, how many natural numbers are factors of 540? This circle represents all the numbers which are factors of 540. This circle represents all the numbers which are factors of 720. Which are factors for 720. Now what is that we require? How many natural numbers are factors for 540? Are factors for 540 but not. So from this I will use colors to represent. From these total yellow circle, if I remove these blue shaded region, I will get the region which I require. Are you all with me? Right? So answer is nothing but total factors for 540. Total factors for 540 minus factors common to 540 and 720. Factors common to 540 and 720, I will get the answer. Factors common to 540 and 720, I will get the answer. Factors common to 540 and 720. What are the factors common to given numbers? Which is nothing but HCF of 540, 720, which is nothing but 180. So total from factors of 540, I need to remove the factors of 180. 540, it is nothing but 180 into 3. 180, it is nothing but 36 into 5. 2 square into 3 square into 5 into 3. It is nothing but 2 square into 3 cube into 5 power 1. Totally how many factors are there? 3 into 4 into 2. So totally 24 factors are there for 540. For 180, how many factors are there? These 180. Totally how many are there? 3 into 3 into 2. 9 2s are 18. 24 minus 18, which is 6. Total factors in that factors for 540. Remove the factors which are common to both 540 and 720. What do you call the factor which is common to 540 and 720? That is nothing but 180. Factors for 540 is 24. Factors for 180 is 6. So answer is, 180 it is 18. 24 minus 18. The answer is nothing but 6. I hope the idea it is clear. Next one. All are very, very good questions, sir. Even this question is also a very interesting question. All these sessions, kindly watch it again and again, then only you will get an idea. Concept, another beautiful question. Concept. Suppose, for example, there is a number 36. There is a number 36. Let me write down the factors for 36 in increasing order. 1, 2, 3, 4, 6, 9, 12, 18, 36. These are the factors for 36. I wrote the factors in the increasing order. Now see, 36, it is nothing but 2 square into 3 square. 4 into 9 is 36. Totally how many factors are there? Number of factors are 3 into 3. Totally 9 factors are there. Am I right? Now if you see here, this is the first factor. This is the first factor from the right. First factor from the left, first factor from the right. Second factor from the left. Second factor from the right. First factor from the left into first factor from the right. It is the number. Second factor from the left into second factor into right. It is the number. Third factor from the left into third factor in the right. It is the number. So, this is nothing but nth factor from left. Nth factor from left into nth factor from the right into nth factor from the right. These is nothing but the original number. Nth factor from the left into nth factor from the right. It is nothing but the original number. Please make a note of this very important key point. Nth factor from the left into nth factor from the right. Now, with this understanding, let us solve the question. Let us solve the question. Now see here. Nth factor from the left into nth factor from the right. It is nothing but the number itself. N is nothing but the number itself. N is nothing but the number itself. Now let us write. Suppose if it is 720. If it is 720. These is nothing but 720 is 2 into 360. 360 is 2 cube into 3 square into 5 power 1. 8 9s are 72, 72 5s are 360. It is 2 power 4 into 3 square into 5 power 1. 2 power 4 into 3 square into 5 power 1. Totally how many factors are there? Total factors for this number. It is nothing but 2 power 4 means 5 cases, 3 cases, 2 cases, 5 into 3 into 2, 5 into 3 into 2. Totally how many factors we got? 30 factors we got. Let me write down. This is the first factor. This is the first factor. This is the second factor, third factor, fourth factor, fifth factor. This is the 30th factor, 29th factor, 28th factor, 27th factor, 26th factor, 26th factor. First factor from the left, 1, 2, 3, 4, 5. If all the factors for 720 are written in an increasing order, the factor which occupies the 26th position. 26th position, where it is, we will see it. This is the first position from the right, second position from the right, third position from the right, fourth position from the right, fifth position from the right. 26th factor which occupies 26th position is nothing but the fifth factor from the right. So what is that concept we discussed? Fifth factor from left, fifth factor from left into right, fifth factor from left into right. This is nothing but the number. Fifth factor from left into fifth factor into right. That is nothing but the number. That is nothing but the number. So what is the first factor? It is 1. 2 will divide, 3 will divide, 4 will divide, 5 will divide. So fifth factor from the left is 5. 26th factor, it is nothing but, if I arrange it, it is the fifth factor from the right. It is nothing but, fifth factor from right is nothing but the 26th position, equivalent to 720. 720 by 5. What will be the answer? Answer is 144. 720 by 5. Answer is nothing but 144. Very, very good question. If the factors are written in the ascending order, if the factors are written in the ascending order, fifth factor from the left into fifth factor from the right, it is nothing but the number itself. Please write down. So the beautiful way of looking at this question is 26th factor, if you are writing it, it is nothing but the fifth factor from the right. To get the fifth factor from the right, if you can list the fifth factor from the left and divide that number with 720, you will get this answer. Another beautiful question. I hope the logic it is clear. I hope the logic it is clear. All advanced level questions, each and every question is carefully handpicked, carefully selected, so that you will learn concepts through solving the problems. Very, very good questions. Next one. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and so on up to 36 digits. Let me write down vertically. 1, 1, 2, 1, 2, 3. Next it is 1, 2, 3, 4. First it is ending with 1, second it is ending with 2, third it is ending with number, it is ending with 3, fourth number it is ending with 4. So nth number it will end with n. Nth number 1, 2, 3, 4 and so on up to n. Up to 36 digits. Now see here. Up to 36 digits. First two numbers, total how many digits I wrote? 1 plus 2, 3. First three numbers, how many digits I wrote? 1 plus 2 plus 3 is 6. First n numbers, total how many digits? Summation n. It is nothing but 36 digits. N into n plus 1 by 2. It is nothing but 36. N is nothing but 8. Clearly visible. 8 into 9 by 2, it is 36. So this n is replaced by 8. I hope the idea it is clear. First number is 1, second number is 1, 2. So second number it is ending with 2, third number it is ending with 3, nth number it will end with 8. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4 and so on up to 8. So first two numbers 1 plus 2. First three numbers 1 plus 2 plus 3. First number summation n is 36. N equivalent to 8. So the last number is nothing but, I will write it again. 1, 2, 3, 4, 5, 6, 7, 8. This is the last number. It is divided by which number? It is divided by 36. 36 is a composite number. So write down it as a product of coprimes. So 36 as a product of coprimes is 4 into 9. What is the divisibility rule of 4? Last two digits should be divisible by 4. 4 19s are 76. What is the remainder? 2. 4a plus 2. 9. 9 is nothing but the sum of the digits. These is nothing but 1. 1 plus 2, it is nothing but 3. 1 plus 2 plus 3, it is nothing but 6. If you see, it is 10. Now if you observe the pattern, it is plus 2, it is plus 3. It is ending with 2, so it is plus 2. Ending with 3, it is plus 3. Ending with 4, plus 4. Ending with 8, it will be 5. It is plus 6. Plus 7, it is plus 8. Plus 8. 3 plus 6, 9 out. 15 plus 21, 36 out. Here also 36 it is out. 2 plus 8 it is 10. Here also it is 1 plus 0 it is 1. Here also it is 1. 1 plus 1 plus 1. Remainder it is 3. So 4a plus 2 equivalent to 9b plus 3. 4a equivalent to 9b plus 1. 4a equivalent to 8b plus b plus 1. Divisible by 4, divisible by 4. B plus 1 should be divisible by 4. So B minimum value, it is 3. 9 3s are 27 plus 3. Answer is nothing but 30. Answer is nothing but 30. Is the idea clear? 1. 1, 2, 1, 2, 3. Sir, the divisibility rule of 9 is sum of the digits. You just, in whatever the way that you add it, the sum of the digits will remain the same. For example, 1, 2, 3, 4. Digital sum is 1. 12 plus 34. If I take a group of two digits, 12 plus 34 is 46. Again it is 1. If I take 1, 2, 3 plus 4, 1, 2, 7. 1, 2, 7, it is also 1. You can take a group of single digits, then 2 digits, then 3 digits, add in whatever the fashion, the answer remains the same. Again I am explaining. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Last number we don't know. Second number it is ending with 2. Third number ending with 3. So last number end with 9. Summation n is 36. N value it is 8. So the last number will be 1, 2, 3, 4, 5, 6, 7, 8. That is clear. It is divided by 36. 36 is 4 into 9. Divisibility rule of 4 is last two digits should be divisible by 4. 4 nines and teens are 76, remainder 2. 9 is the sum of the digits. There is a pattern that is forming. 1, next it is 3, plus 2, plus 3, plus 4. Number ending with 4, plus 4. Number ending with 5, plus 5. Number ending with 8, plus 8. Then delete the digits whose sum is 9. Very, very good question. Answer for this question is 30. Answer for this question is 30. I hope the idea it is clear. Another one. What is the remainder when 41 factorial whole square is divided by 83? Is divided by 83. The 83, it is a prime number. So when the denominator, it is a prime number and there is a question on factorial, you can use the concept of Wilson's theorem. Wilson's theorem states remainder when p minus 1 factorial divided by p, it is p minus 1. If p is a prime number, first make a note of these important key points. P minus 1 factorial divided by p, it is p minus 1. Remainder when p minus 2 factorial divided by p, it is nothing but 1. Remainder when p minus 3 factorial, p minus 3 factorial divided by p, these is nothing but p minus 1 by 2. Please make a note of these three important concepts. If p is a prime number, if the denominator it is a prime number, you can, and the numerator it is a factorial. P minus 1 factorial by p is p minus 1, p minus 2 factorial by p is 1, p minus 3 factorial by p is p minus 1 by 2. These three will be extremely useful when the denominator it is a prime number. For example, 14 factorial divided by 17. It is of the form p minus 3 factorial by p. Answer is 17 minus 1, 16 by 2. Answer is 8. 21 factorial divided by 23. P minus 2 factorial divided by p. Answer is nothing but 1. Answer is nothing but 1. I hope the idea it is clear. P minus 1 factorial. So 22, how it is derived? Because 22 factorial divided by 23 is 22. 22 factorial is 22 into 21 factorial. 22 by 23 remainder is 22. 21 factorial by 23 has to be 1 because 22 into 1 is 22. These three please make a note of it. P minus 1 factorial by p, p minus 2 factorial by p, p minus 3 factorial by p, as long as p is a prime number. Now from based upon this, let us solve this question. Question is remainder when 41 factorial whole square divided by 83. 41 factorial whole square divided by 83. Now this is nothing but, let us start with p minus 2 factorial. 81 factorial divided by 83. It is nothing but 1. 81 factorial, it is nothing but 1 into 2 into 3 and so on up to 41. Next one 42, 43 and so on up to 81 divided by 83. It is nothing but 1. 81 factorial is 1 into 2 into 3 and so on up to 41. 42, 43 and so on up to 81. 1 into 2 into 3 till 41. These is nothing but 41 factorial. 42 by 83. 83 ones are 83. Negative remainder minus 41. 83 ones are 83. It is minus 40. 83 ones are 83 minus 2. Divided by 83. It is nothing but 1. So 2 to 41. There are 40 numbers are there. 40 numbers negative. If I multiply, I will get positive. So this answer is nothing but 41 factorial whole square when divided by 83. Answer is nothing but 1. I hope the idea it is clear. 1 into 2 into 3 till 41, it is 41 factorial. 83 ones are 83, minus 41, minus 40, minus 2, 41 to 2. There are 40 negatives, product is nothing but plus. So 41 factorial whole square divided by 83, it is nothing but 1. Idea clear? Very, very good question. Not directly based on Wilson's theorem. Generally, a lot of teachers discuss p minus 1 factorial, p minus 2 factorial, p minus 3 factorial. Questions can also be like this. Even the question can also be like this. Let us develop another question. Reminder 1. 17 factorial is divided by 23. 17 factorial is divided by 23. This is nothing but 20 factorial divided by 23. 23 minus 1, 22 by 2. It is nothing but 11. What is the concept that we are using? It is remainder 1. P minus 3 factorial divided by P. It is P minus 1 by 2. If P is a prime number. 20 factorial, it is nothing but 20 into 19 into 18 into 17 factorial divided by 23. It is nothing but 11. 20 divided by 23 minus 3. 19 divided by 23 minus 4 minus 5. 17 factorial divided by 23. I don't know. Even if I further divide, remainder does not change. Minus 3, minus 4, minus 5. 3 4s are 12, 12 5s are 60. 23 3s are 69. Minus into minus. 9x when divided by 23, it is nothing but 11. Till here clear, right? 23 ones are 23. Minus 3, minus 4, minus 5 into x. 3 4s are 12, 12 5s are 60. 23 3s are 69, minus 9. So 9x when divided by 23, quotient is k, remainder is 11. Dividend equivalent to divisor into quotient plus remainder. 9x is nothing but 18k plus 9 plus 5k plus 2. Why am I writing like this? You will understand in the next step. It is divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. 5k plus 2 is 9, k is a fraction. 5k plus 2, 18, k is a fraction. 5k plus 2, 27, k is 5. K minimum value, it is 5. 5k plus 2 should be divisible by 9 and k should be a natural number. So these are nothing but 9x equivalent to 23 5s are, how much it is? 115. 115 plus 11, 126. X is nothing but 14. Very, very good question. Advanced question based on Wilson's theorem. Please understand, if you probably don't know p minus 3 factorial divided by p as p minus 1 by 2, then this problem will be very difficult. 20 factorial by 23, it is 11. 20 factorial is 20 into 19 into 18 into 17 factorial. 23 ones are 23, minus 3, minus 4, minus 5. 3 4s are 12, 12 5s are 60, 23 3s are 69. 9x divided by 23, it is 11. So dividend equivalent to divisor into quotient plus remainder. So k is 5. 5k plus 2 cannot take 9. Why? Because k will be fraction. 5k plus 2 cannot take 18. K will be fraction. 5k plus 2 can take 27. K is 5. Answer is nothing but 14. I hope this idea it is also clear. Another one. 2 power 28. 2 power 28 minus 1. It is exactly divisible by two numbers. This 2 power 28 minus 1 has got so many factors, out of which there are two factors are there. There are so many factors whose product will be equivalent to this number. There are two factors which lie between 120 less than A1 A2 less than 130. There are two factors which will perfectly divide. 2 is an even number. Even power anything even. Even minus 1 odd number. Even minus 1 odd number. Left hand side it is an odd number. So odd number will always be a product of odd 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 odd. That means definitely A1 will be an odd number. Odd into odd into odd into odd. Then only I will get odd. A2 will also be odd. What is the question? Sum of these two numbers. Odd plus odd. Odd plus odd is nothing but an even number. Answer should be even. Answer should be even. First case. So directly just by looking at a question, you can eliminate 255 and 257 because both are odd numbers. 2 power 28 minus 1 even minus 1 is odd. Odd will be resultant based on odd dot 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 only. Suppose 35 is there. 35 is a number. 35 is an odd number. Odd number is the product of all odd numbers only. 1 into 35, 5 into 7. Are you all with me? Right? Odd plus odd, it is even. 2 power 28 minus 1. These is nothing but 2 power 7 power 4 minus 1 power 4. A power n minus b power n. It is always divisible by a minus b and a plus b. A power n minus b power n is always divisible by a minus b and a plus b. As long as n is an even number. Minus 1 plus 1 cancel. 2 power 7 is 128. Again it is also 128. 128 plus 128. Answer is nothing but 256. I hope the idea it is clear. 128 plus 128. Answer is nothing but 256.